the second video on 5.7, still applying the fundamental theorem of algebra, but this is going to be something that takes concepts that you're familiar with and puts it together into kind of a new type of a problem. So in the intro video, I talked about conjugates, so a couple theorems, but I think you know these already. If you have a polynomial function with real coefficients, so you should not have any i's in your polynomial, and you know that a plus bi is an imaginary zero of the function, then a minus bi is also a solution. So in more simplistic terms, is that your imaginary solutions should always come in pairs. Okay, so you should never have one imaginary solution. And think about the quadratic formula. Again, in quadratic formula, you always have the plus or minus piece of that. Hence, imaginary just can't be a standalone solution. Okay, the irrational conjugate theorem, same thing, says if you have a polynomial function and a plus the square root of b is a 0, then a minus the square root of b also has to be a 0. The concept itself is not challenging, but sometimes it's tricky to remember that if I have the solution 3i, that negative 3i should also be a solution. Or maybe 2 plus root 3 over 5 is the solution. Well, then 2 minus root 3 over 5 is also a solution. You just need to know they always come in pairs. All right, here we go with your first example. And this might be a good enriched assessment question, hint, hint, hint. So it says, write a polynomial function of least degree that has real coefficients and a leading coefficient of 1, and negative 2 and 3 plus I are zeros. Okay, so I want you to stop and think about this. I know that I have one solution, two solutions, so does that mean I have a quadratic function? The answer is no, but how do I know it's not quadratic? What do you know about the solution of 3 plus I? I hope you caught this, that 3 minus I is also a solution. Remember, imaginary solutions always come in pairs. This is going to be the tricky part, okay? If you don't catch that, you think you have two solutions, but you really have three solutions, okay? So first of all, when it says to write a polynomial of least degree, here I know that it's going to be a third degree function because I have two imaginary and one real. Now, could one of those be repeated? Absolutely, but when it says of least degree, you don't have to worry about that. So that's the good news. Okay, so then it has to have a leading coefficient of 1, so I don't have to worry about finding a. That's good news. And it has real coefficients, so when you set this up and get it all in standard form, you should not have any i's in your problem. Okay, so let me clarify this. I know negative 2 is a solution, so I'm going to write y equals x plus 2. And you'll see why I'm doing this in a second. But just remember, if I have a solution of negative 2, I know its factor is x plus 2, right? Always the opposite sign, so if I solve this factor, I'd get that solution. Now, we've never done this with imaginary, but conceptually it's going to be the same thing. So if I have a 0 of 3 plus I can write it as a factor of x minus quantity, be careful here, 3 plus I, because technically here I'm doing x minus a negative 2, which is x plus 2. So I'm going to do x minus that and x minus that. Okay, so bottom line is you're always writing x minus whatever that 0 is. Now you're going to see some patterns as I go through this and take advantage of those and shortcut this. That's totally fine. But the first thing you might note, of course, is that when you distribute this negative through, it's really going to be x minus 3 minus I. This is going to be x minus 3 plus I. And I would, just to make my life easier, probably just start there. So I'm going to just distribute that negative through, so x minus 3 minus I, and same thing here, x minus 3 plus I. Okay, now remember it says here that we have to have real coefficients. Well, these have imaginary pieces in it. What do I have to do to solve that problem? I have to FOIL this out. And remember, when you FOIL out factors that are conjugates, those i's should wipe out, and you're going to see this happen. So if it doesn't wipe out, you've done something wrong. I know that's easier said than done. So I'm going to start by foiling these two, because if I foil out my conjugates, my i's should be gone, and if not, then I can go back and fix my problem. So I'm going to ignore that x plus 2 for just a second and create kind of a big mess here. So I'm going to multiply all of this out. So x times x is x squared, x times negative 3, x times I. Then I'm going to go to my negative 3, negative 3 times 3, negative 3 times I, and then I'm down to my negative I. So negative xi, positive 3i, and negative I squared. Okay, and now I'm going to look at everything I have here. So note that my positive xi and negative xi cancel out. Negative 3i, positive 3i cancel out. Okay, so I'm going to reduce this since I have some things that just canceled out. So I have x squared minus 6x, right? Then I have a plus 9, and what is I squared? Remind yourself I squared is negative 1. Make yourself a huge note. So this is really minus a negative 1, so plus 1 plus 9 is plus 10. Okay, I'll say that again. I squared is negative 1, so this is really minus a negative 1. Minus a negative 1 is plus 1. Plus 9 is plus 10. Okay, now, last but not least, I FOIL out my binomial and my trinomial. Before I do that though, note, all my i's are gone. That should happen. Yay! So now I just FOIL this. So I get x cubed minus 6x squared plus 10x plus 2x squared minus 12x plus 20, and combine like terms. So I have a negative 6 plus 2, which is negative 4, x squared plus 10 minus 12, so minus 2x, and then plus 20. Okay, and there is my polynomial function of least degree, cubic, right? All real coefficients. I don't see any i's in there, and my leading coefficient is 1. Not too bad, definitely a lot of work. Okay, I'm going to do one more, and what I'm going to do with this one is I'm going to set it up, and then I'm going to have you pause the video and make sure that you can work it out. So write a polynomial of least degree that has rational coefficients and a leading coefficient of 1, and 4 and 1 plus the square root of 6 are zeros. Okay, so again, tricky, you know you have one solution, two solutions, but you also know that 1 minus the square root of 6 is a solution. So least degree, I should have a third degree function, right? And you just have to remember that not only do imaginary solutions come in pairs, but irrational solutions come in pairs. So I'm going to set this up. If I know 4 is a solution, I know x minus 4 is a solution. If 1 plus root 6 is a solution, I know x minus, in parentheses, 1 plus root 6. And then x minus, in parentheses, 1 minus root 6. Now what I think you should do is take a second, pause the video, you multiply this all out, and then we'll compare answers. So again, these are the ones you should multiply first because they're conjugates, and those radicals should cancel out just like imaginaries cancel out. So give it a shot. And the first thing I did was distribute this negative through. So negative 1 negative root 6, negative 1 positive root 6. So stop there. If you made that mistake, start again. And then I'm going to FOIL out my irrational pieces. So x times x is x squared minus x plus x root 6, a little awkward, minus 1x plus 1 minus root 6 minus x root 6 plus root 6, and square root times square root cancels out, but I'll just write that as minus the square root of 36 in case you don't see that. Okay, now let's see what cancels out, and hopefully my roots do. Yep, plus x root 6 minus x root 6, plus and minus square root of 6. I know square root of 36 is really just 6, so that's a real number. So now I'm going to simplify some things here. Okay, so I have x squared minus 2x plus 1 minus 6 would be a minus 5. Now double check everything. And my last step is to FOIL out the binomial and the trinomial. So again, see how you do. So here we go, x cubed minus 2x squared minus 5x minus 4x squared plus 8x plus 20. And I can combine like terms. So I have minus 6x squared minus 5 plus 8 is plus 3 and plus 20. And there's my cubic function of least degree with a leading coefficient of 1.